So up until now, whenever you've been working with a line, you were given the equation y equals b plus mx or y equals ax plus bx. So I'm just going to jot that down here for a minute. Y equals b plus mx. Sometimes it's useful to be able to go to a specific place on the grid, and once you're there, then travel at this particular slope. So the question is then, if I have this information, can I generate this formula? So if you look at the numbers that you've been given, this 2/3 there, it says right there that that's the slope, this thing here. So that goes into this model for M. And when you're given a set of points, the first number you see in an ordered pair is always an x value, and the second number you see in an ordered pair is always a y value. So if you look at this model we've got sitting here, I have a number for y, that's 5. I have a number for m, that's 2/3. And I have a number for x, that's 6. The only thing that isn't solved for is b, right? The y-intercept. But if you were to put this number here, and this number there, the only letter left is the y-intercept, and you can use your algebra and BEDMA skills to get all of the other numbers together and calculate an answer for this. So I'm going to give that a try here. So because the line passes through 6, 5, the y value will be 5. I don't know what b is, but I know that the slope is 2/3. And I know that the x value at the place that I'm trying to go through is 6. So if I can work that out, I should be able to get a value for b. So first things first, I see 2/3 of 6. There's no letters involved here, so I'm going to do that so that it's a little cleaner than this. Now, fractions have never actually really been a thing. They're just multiplications and divisions that weren't convenient to do because they didn't go cleanly. So this thing here says 2 times 6 divided by 3. So I'm just going to rewrite it like that. 2 times 6 divided by 3. Whatever's in the denominator of the fraction, or the basement, the bottom part, is what you're dividing by. Anything that's in the top is what you're multiplying by. So if you just decode this fraction back into the multiplications and divisions that you were saving for later, it's a little easier to calculate. So 2 times 6, that's 12. 12 divided by 3 is 4. And now I need to get this 4 to the other side. So if I want to undo adding 4, I need to subtract 4. So I end up with b equals 1. Now you just sort of fact check yourself on there. I don't know what this number is. It's a mystery number. But if I add 4 to it, I get 5. If you didn't add 4 to it, there should only be 1 there, right? Like 1 plus 4 is 5. You can just sort of feed your answer back up into here to make sure you're correct. So I was given an m, and I calculated a b, and I'm trying to put it into this format here, this y equals b plus mx form. In this format, there's not a number here. It's always a y, and there's not a number here. Because we aren't picking specific points, we're saying all the points that satisfy this equation. It's this number and this number that have to be filled in. Well, I have them now. B is 1, and m is 2/3. So there you go. That's the equation of a line that has a slope of 2/3 and passes through 6, 5 on the Cartesian plane. We'll just run one more example of this with same idea. I want to find the equation of a line that has a slope like this and passes through this particular point. So you start with your model, your y equals b plus mx. I'm going to have to be able to fill in 3 numbers here in order to use this to calculate the force. So I need a y value. That's here, because I know the line passes through -7 on the y. B, I don't know yet. M, I have a slope, that's -4/5. So instead of writing plus here, I know it's a line that drops instead of rising. Now I need an x value. I'm going to use 15, because I know the line passes through 15 on the x coordinate. All right, so just like the last example, the only thing to do here is to solve for b. So I'm going to take this fraction and I'm going to spread it back out into its multiplication and division parts. And then I can just work it out. -4 times 15 is -60. And then -60 divided by 5 is -12. So to get rid of this -12, I'm going to have to add it to the other side. And -7 plus 12 gives you +5. So the equation of a line that has a slope of -4/5 and passes through 15, 7 would be y equals -5 minus 4/5 of x. And that's it. If you want to check these when you're done, you can always take the x value and pop it in here and see what you get. So just to show you how to do that, y equals 5 minus 4/5 of 15. Now, if I've done all this correctly, when I work this out, I should have it say -7, because this line, this equation, is supposed to spit out the y coordinate that goes with the x. And I already put in 15 for x. So, -4 times 15 divided by 5. 4 times 15 is 60. 60 divided by 5 is 12, and 5 minus 12 is -7, which is what I wanted to do, or wanted it to do. So I know that this equation for that particular line is behaving the way I wanted it to.